goal of today's lesson is to solve inequalities in one variable and then represent their solution sets. So if you recall, which is what the do now is walking us through, we have solved inequalities, represented their answer in inequality form, number line form, words, and set notation. So just filling in this chart, if I have the equality x is greater than or equal to 2, I put a closed-in circle because it's equal to over the 2. Since it's greater than, I'm going to the right. My solution in words is the set of real numbers, using the symbol, greater than or equal to 2. And then in set notation, x is real, x is greater than or equal to 2. Okay? One of the things to be very careful about is when you are reading an inequality, always read the inequality starting from the variable. And what I'm referring to is if your inequality was written this way, students would try to read this left to right and say that it's 2 is less than or equal to x. Yes, that is a true statement, but the problem is when you see the words or hear the words less than, you think you're going to go to the left on the number line as opposed to the right. So you can just simply flip this inequality, the open side is to the x, and rewrite it that way. That will save you making some careless mistakes. Okay. The second one, the set of all real numbers less than -4, x is less than -4. Since it's only less than, I have a, and I'll just find out where it is, 1, 2, 3, 4, open circle going to the left. And it's the x is real and x is less than -4. Next one, we see that x going to the left is less than, filled in circle, equal to 4, the set of real numbers less than or equal to 4. And then again, x is real and x is less than or equal to 4. And then the final, we see x is greater than -2. We're at -2, open circle going to the right, and the set of real numbers less than -2. Now, so far what you've seen is that the set notation is basically almost the same as what's in this first column here. Okay? The point is, what we're going to do today is we are going to solve an inequality so that we get down to what the answer is in the first column shown. So let's go through some examples. I want to solve these inequalities. Very straightforward. X is greater than 4. And now I want to check their answers. Now I'm only going to choose one because it becomes redundant. So what is a number greater than 4? 5. Is 5 plus 3 greater than 7? Yes, so I'm comfortable and confident that I am correct. The next one, I add 4. Divide by 3. X is less than or equal to 5. What value satisfies that? Again, 4 works. Is it a true statement? Yes. Now, one of the key things to be careful of, when you are choosing a value to substitute in to check if your inequality is correct or not, never choose the value that you came up with as an answer, for example, 5. Because when you shade this and you have a filled in circle, you would be shading to the left. Well, if you chose 5 to substitute in, that doesn't tell you your shading is correct because 5 makes this an equal. And we don't want what makes it equal. We want what makes it either less than or greater than according to the inequality. Now, the last one, I want to show you a step here, and everyone viewing this video, don't freak out when you see what I'm going to be doing. It's purposeful. The natural inclination is I divide each side by -2, and I get x is greater than or equal to -3. Then I say, well, what's a value greater than or equal to -3? And -2 works. Hopefully you'll notice that that is not a correct statement. If this isn't a correct statement, then that means your inequality is incorrect, which means it should look like this. Well, what's a value less than or equal to -3? -4. And you'll see now my statement is true. So, what is the thing that you have noticed here? Because I divided by a negative, you may remember the rule that to keep an inequality true when dividing or multiplying by, that's the key, a negative, you reverse the inequality symbol. Okay? So, just to show you a demonstration of that, we can all agree that 6 is less than 10. If I were to multiply each of these numbers by, let's say, -2, this becomes -12, that becomes -20, but it results in the change of my inequality symbol. And it would be the same thing if I divided by -2. Doesn't matter. All right? So, bottom line, when you are solving inequalities, you are going to go through all of the same steps as if it were an equation. And the only thing you need to be aware of that's different is when you divide or multiply by a negative, you reverse the inequality symbol. So let's walk through each of the next 6 examples. I am going to solve this by first distributing the 2. Combine like terms on the same side. Please remember your steps. Use the property of equality to add 1 to both sides. And divide by 2. So x is greater than or equal to 21. I'm just going to show you this in the number line because the set notation and in words is pretty redundant. You only need 3 hash marks for your number line. The solution should be in the middle, 1 above, 1 below, or counting by equal number of units. It's filled in circles since it's equal to, and it's greater than, I'm going to the right. Okay. Scrolling down. Again, I'm solving an equation or inequality here, the same as an equation. Variables on one side, numbers to the other. Add 1. 16 is less than 4x. Divide by 4. Now, you would read this as x is greater than 4, and you can reverse it if it helps you visually. 3, 4, 5, open circle. I read it as x is greater than 4. I'm going to the right with it. Okay? I'm going to move on to the next 2 problems. You can always pause the video if you need to. Now, I have variables and numbers on both sides. You have 4 choices of what you can do here. My recommendation is to get rid of one of these 2 variables and try to keep it positive if possible. Well, subtract 2x from both sides. 24 is less than or equal to 4x minus 8. No choice but to add 8 now. 32 is less than or equal to 4x. Divide by 4. you would read this as x is greater than or equal to 8. Go to my number line. Sorry that my hashes aren't symmetrical, but doesn't matter. Greater than, going to the right. Okay. Now I want to look at the last 3 problems. Going the wrong way. There we go. Now, you have some choices for problem number 7. We see the dreaded fraction. So, one thing you can do is you can multiply everything by the LCD of 2. You get 6 minus x is greater than or equal to 12. Okay? Because I multiply all 3 terms by 2, otherwise the equation does not stay balanced. I subtract 6 from both sides. Be careful, negative x is greater than or equal to 6. I then have to divide or multiply by negative 1 to get x is less than or equal to, you can't see it there, a negative 6. Okay? So, go to my number line, negative 6, negative 5, negative 7, filled in circle to the left. Okay? Now, this is the type of problem that may make sense to check. So, if I wanted to check 3 minus x over 2 is greater than or equal to 6, and I want to put a value in for x, well, it's any value less than negative 6. I don't want to choose negative 6. Okay? I don't want to choose negative 7 because it gives me a decimal, although you can. So I'm going to choose negative 8. Please be careful of your signs. 3 minus. It's a double negative, so it becomes plus 4. And then you'll see that that is true and works out. Okay? The other thing, and I'm going to erase this so that I can show you the alternative that you could have done here, because I know some students were doing this in class, okay, is I subtract 3 from both sides. Be careful. You are left with negative x over 2 is greater than or equal to 3. Now, to get x by itself, I have to multiply by negative 2. All right? Because the negative times a negative makes this a positive x. This is a negative 6. Since I multiply by a negative 2, flip the sign. Okay? Remember, when you check your answer, like I'm doing over here, you always substitute into the original inequality. And you do not reverse this when you're checking your answer, because your answer, when checking, is all numerical. You're just checking if that's a correct numerical statement. All right? Number 8. Hopefully you'll see you use the distributive property first. Negative 2x plus 4 is greater than 22 minus 5x. Okay? I am distributing twice. Okay? Then I want to get all my x's to one side. Let's keep them a positive. Not fatal if you don't, but it cuts down on mistakes. Subtract 4. 3x is greater than 18. Divide by 3. X is greater than 6. Go to my trusty number line. 5, 6, 7. Going to the right. Okay? So far, all of this should be just a refresher on solving equations and just graphing your solutions, just being careful about switching your inequality symbol. Now let's go to the last one. Again, I'm going to solve first by using the distributive property. 3x minus 15 minus x. Nothing to do on the left side. Combine like terms. Now, you may notice this here, but that's okay. Get rid of the 2x. You are left with the statement 5 is greater than negative 15. The x's have been canceled out. You should hopefully remember this from when we were solving equations. And if we ended up with a true numerical statement, meaning the variable is canceled, this is a true statement, then my solution is all real numbers, so that I would just represent it as such. If I ended up, let's say, for argument's sake, it was a reversal, so that this was this way, which is a false statement, then there would have been no solution. Okay? And you would have either used the empty set or the zero, and then you would have left your number line blank. So in this situation, since this is a true statement, any real number that you substitute in for x will work, any and all. If the inequality were reversed, meaning it's a different problem, okay? All I'm doing is now saying, suppose the original inequality were this way, then that would have left you with this statement, which is clearly false, which means there is no real number that would work in this scenario. Okay? So, a couple of summary points on inequalities. You solve them the same way as if you were solving an equation, except you have to be careful with regard to multiplying or dividing by a negative, which would result in you reversing the inequality symbol.